What secret is NASA keeping about the most mysterious visitor our solar system has ever seen?
No explanations. No access. The world is left guessing. If 3I Atlas is just another cosmic rock, why hide the evidence? If nothing is unusual, why keep the data from public view?
To truly appreciate the odds, imagine rolling a die with 10,000 sides and landing on the winning number on your first try. That is the scale of rarity we are dealing with, a cosmic alignment so improbable that it demands explanation. Over the centuries, astronomers have cataloged millions of comets and asteroids, yet nothing has ever moved quite like this. Earlier this year, astronomers spotted something nearly impossible. An object from deep space, known as 3I Atlas, hurtling on a trajectory so rare that cosmic odds makers would call it a miracle. Its path does not just cross Earth's orbit, it is aligned in a way that brings it alarmingly close to our inner planets. The chance of this happening by accident is less than 1 in 10,000.
When the James Webb Space Telescope, humanity's sharpest eye in space, pointed at 3I Atlas, it gathered an immense 40 gigabytes of detailed data. For context, that is the equivalent of over 8,000 high-definition movies worth of raw, unfiltered cosmic information. Yet, despite the historic nature of this observation, something inexplicable followed. Suddenly, the entire dataset was locked away. No images released, no announcements. NASA and its scientists offered only silence.
To grasp the importance of what is at risk, we need to look closer at what makes 3I Atlas so unique and why its brief visit could rewrite everything we know about our place in the universe. Let us break down the bizarre details of 3I Atlas's arrival and why every anomaly demands our attention. The story begins long before NASA locked the doors. What makes this new, shadowy visitor so different from any cosmic wanderer we have ever seen? This secrecy raises the stakes. If we dismiss the questions or let this silence stand, we may lose our only chance to investigate what could be an artificial messenger from another star. Inside those files could be clues to technology beyond our understanding, or proof that we are not alone. Ignoring this means we might never discover who or what sent 3I Atlas to us. In the early months of 2024, astronomers caught sight of something remarkable, an object racing into our solar system from the dark between stars. Named 3I Atlas, it is only the third known interstellar arrival in the entire history of human observation, a cosmic rarity that challenges everything we thought we knew about what drifts between worlds. To put this in perspective, the first interstellar object, Oumuamua, was detected only in 2017. Before that, the idea of objects wandering between stars was mostly theoretical. In the entire 5,000-year history of astronomy, only 3 such objects have ever been found: Oumuamua, Borisov, and now 3I Atlas. Each has brought with it mysteries and more questions than answers. For comparison, the vast majority of comets and asteroids enter the solar system at odd angles, obeying the chaotic physics of gravity and chance. Retrograde motion is rare, seen in only a tiny fraction of known bodies. For an interstellar visitor to arrive in this manner is not just uncommon, it is unprecedented. From the moment of discovery, 3I Atlas broke every rule. Instead of tumbling in on a random orbit, it sliced through the solar system in almost perfect alignment with the flat, delicate plane where our major planets circle the sun. Even stranger, it moved in reverse, a retrograde path, directly opposite the planet's flow, something seen in only a handful of objects across all the skies we have ever mapped. If we let this moment slip by, we risk losing far more than scientific bragging rights. We may be forfeiting humanity's only chance to study alien technology or a message sent across the gulf between stars to our very doorstep. Every day that passes, the opportunity fades, and the mystery grows colder with distance.
This made it the ideal quarry for the James Webb Space Telescope, the most powerful observatory ever built by humanity. For the first time, we could capture exquisite detail on a visitor from another star system as it made its fleeting passage. Webb turned its infrared eye on 3I Atlas and gathered more than 40 gigabytes of spectral data, a digital trove that could reveal its makeup, structure, and perhaps even its origins. The odds against this are breathtaking. The chance of an object following such a path is less than 1 in 20,000. Imagine every person in a small city flipping a coin at the same moment, and only one landing heads. Interstellar debris should arrive at wild, unpredictable angles, not with this eerie, surgical precision. Yet 3I Atlas threaded a path so close to Mars, Venus, and Jupiter that it seemed less a random traveler and more a guest following a set itinerary, skimming past our neighbors as if by design before heading back to the void. But then, the signals stopped. There were no images, no public announcements, not even a whisper from official channels. Almost overnight, the data were locked away under an ironclad embargo, hidden not just from the public, but from scientists worldwide. No reasons were given, only a silence as deep as the space 3I Atlas came from, sealing away what could be the most consequential interstellar discovery of our time. But silence breeds suspicion. What is so extraordinary about 3I Atlas that it must be kept from the world? Why do only a handful of scientists get to glimpse the cosmos' secrets, while billions remain blind to discoveries their own taxes paid for? This time, the secrecy is not universal. One team observing 3I Atlas clings to the embargo tradition, refusing to release their findings. Another group, defying the norm, shared their data instantly, letting the world watch discoveries unfold in real time. Still, the most revealing dataset remains hidden, accessible only to the original researchers. Embargoes are meant to protect scientific credit and ensure careful analysis before results go public. But when it comes to a fleeting, never-to-return object like 3I Atlas, these old rules feel dangerously out of place. There will be no second chance to examine this interstellar visitor. If the moment is lost, so is the opportunity to spot something extraordinary lurking in the numbers. Avi Loeb, the outspoken astrophysicist renowned for his work on Oumuamua, argues that cosmic anomalies demand transparency, not secrecy. He warns that when science prioritizes caution and competition over openness, we risk missing vital truths that could rewrite our understanding of the universe. The James Webb Space Telescope, funded by people across the globe, captured precious data on the interstellar visitor known as 3I Atlas. Yet, instead of sharing its findings, Webb's team locked the crucial data away under embargo, a protocol that can keep results secret for up to 1 year. No outsider, not even fellow astronomers, can access the telescope's richest trove, a detailed spectral cube that could change everything. Yet even as the world waits, an unexpected twist threatens to close the window on this cosmic mystery for good. If secrecy triumphs over transparency, humanity could lose its best shot at decoding a message or technology from beyond our star. The chance to learn, to understand, and perhaps even to contact another intelligence might slip through our fingers forever. A sudden technical failure strikes the Webb telescope's data systems. In mere hours, the team faces a desperate race against time to salvage what remains. This is not an empty warning. History is full of examples where caution and secrecy delayed discovery. In the early 20th century, the Wright brothers kept their flight technology secret, slowing the spread of powered flight. In physics, the Cold War secrecy around nuclear research led to missed opportunities for collaboration. Every time knowledge is locked away, progress suffers. The odds surrounding 3I Atlas are staggering. Its path is retrograde, moving opposite to the planets. It aligns almost perfectly with Earth's own orbit and passes close to the orbits of Jupiter, Mars, and Venus in rapid succession.
According to Loeb, the chance of all these alignments happening by accident is less than 1 in 5,000. Its looping flybys and uncanny elliptic alignment hint at intent, or at the very least, a phenomenon never seen before. At last, the cosmos tosses us a clue, but in a cruel twist, we are poised to blink just as the secret reveals itself. Technical failures are not just inconvenient, they are catastrophic in astronomy. In 1999, NASA's Mars Climate Orbiter was lost due to a simple unit conversion error, resulting in a $200 million loss. In this case, the potential loss is not just money, but the only close-up look humanity will get at an interstellar visitor for generations. By the time the object slips out from behind the sun, it will be cooling swiftly, its outgassing fading, its features blurring back into the void. It will accelerate outward, vanishing into the night. The one window for close study will have slammed shut. In astronomy, there are no second chances. No one can rewind the heavens to recapture what slipped away in sunlight. 3I Atlas is about to make its closest approach, perihelion, skimming near our sun, in a rare, possibly transformative moment. This is when interstellar objects can erupt with activity, changing before our eyes. Yet Earth will be stranded on the far side of the solar system. The sun itself becomes an impenetrable veil, blinding every telescope and probe with its glare. At the precise instant when 3I Atlas might bear its mysteries, we will be forced to look away. Can any spacecraft race to meet it? 2 robotic explorers, NASA's Psyche and the European Space Agency's JUICE, will pass tantalizingly close to 3I Atlas. But in deep space, every maneuver is paid for with years of planning and the fate of billion-dollar missions. Diverting either one would threaten their science goals, risking a decade's work for a gamble with razor-thin odds. There is no margin for error, and the time to decide is now. Hesitation means never. Let's consider a historical parallel. In 1986, the European Space Agency's Giotto probe was hastily redirected to intercept Halley's Comet. The gamble paid off, providing the first-ever close images of a comet's nucleus. But that mission was years in the making, and the risks were enormous. Now we face an even tighter window and far higher stakes. If planners hesitate, the opportunity is lost forever. Desperation breeds bold ideas. Some propose reprogramming Juno, a probe now orbiting Jupiter, to intercept 3I Atlas in 2026. But the plan is fraught with peril. Juno was not built for this chase. Altering its path could sacrifice decades of discoveries, all for a long shot with no guarantee. If planners play it safe, or if bureaucracy and fear hold sway, humanity's best shot at direct contact with an interstellar visitor could slip through our fingers, perhaps forever. This is not merely about missing a rare celestial event. It is about losing answers to questions we may never get to ask again, a silence that could last lifetimes. The universe is offering us a message, but we hesitate at the threshold. And that hesitation forces us to confront a darker thought. What if this pattern of missed chances and lost data runs deeper, woven into humanity's approach to the unknown? The clock is ticking, and the next decisions may define our legacy as explorers. Are we bold enough to seize this moment, or will we let the cosmos close its door one more time? Are we moving so carefully, so slowly, that we risk letting something extraordinary slip past, unrecognized? What links these objects is not only their interstellar origins, but how their sheer strangeness pushes against our assumptions. 3I Atlas, in particular, follows a path so sharp and deliberate it almost feels intentional. The little data we have is puzzling, and the data we truly need is locked away behind embargoes. In an era of record-breaking telescopes, why are we hiding the most crucial findings from ourselves? Before the year 2017, humankind had never seen a visitor from another star. Now, within less than 10 years, we have witnessed 3. First came Oumuamua, then Borisov, and most recently, 3I Atlas.
Each new arrival has only deepened the mystery. Instead of clarity, we are left with even stranger questions. Trajectories that defy our models, speeds that seem impossible, alignments that hint at purpose. The real barrier is not the distance between stars. It is the slow, risk-averse machinery of our own institutions. Layers of approvals, guarded data, and a fear of being wrong combine to bury anomalies that might hold the key. By clinging to safe explanations and keeping secrets, we could be turning away from evidence that would change our view of the universe forever. Astrophysicist Avi Loeb urges his peers to follow the evidence, no matter how unsettling. He warns that dismissing or concealing anomalies repeats an old, costly mistake, one where discoveries were ignored until they slipped from our grasp. History is littered with missed opportunities, and the price is always steep. Lost knowledge, damaged credibility, and the risk of being unprepared for what comes next. If this is not a cover-up, then why does every detail feel so much like one? But what exactly makes 3i Atlas so unique, so provocative? To understand, we need to look more closely at what the data and the silence are telling us. Maybe the universe is not silent at all. Maybe we have just failed to listen. Our instruments are ready, but our processes and our courage are not. Unless we change that, we will keep overlooking the very answers we claim to seek. If science does not become more open and daring, we could miss the chance to recognize the evidence of intelligent life, even as it passes right by us. This is more than just a scientific rivalry. It is about humanity's place in the cosmos and the legacy we choose to leave for those who come after us. What are we losing by waiting? Chemical patterns that could reveal the birthplaces of distant worlds, unusual signals in the spectrum, faint clues that might hint at technology or even intention. The chance that this object carries a message from another civilization, lost not to the void of space, but to bureaucracy and hesitation. Each hour of silence is a risk that we let history slip past, irretrievable. Consider what has happened. An object from another star system, 3i Atlas, enters our solar neighborhood, moving in ways that defy familiar physics. Its path and behavior provoke questions that could overturn everything we think we know about life, intelligence, and the universe itself. Yet instead of a global surge of investigation, we are met with silence. Instead of open collaboration, we find closed doors and withheld data. Is this really about protecting science, or are we only protecting egos and reputations? The James Webb Space Telescope, paid for by the public, aimed its unmatched sensors at 3i Atlas and recorded the deepest dataset ever collected on an interstellar visitor. But those findings are locked away, accessible only to a select few, even as time ticks down. The very rules meant to advance discovery now seem to be used as shields against it. This is not an ordinary moment. Interstellar visitors are rare. Decades or even centuries may pass before the next one. 3i Atlas will soon vanish into the dark, and with it, every unanswered question. If secrecy wins now, when will we ever be bold? If not for this, what discovery could possibly be worth the risk? But what can we as individuals actually do? Here are some practical steps that anyone can take to push for greater transparency and scientific courage. The cosmos offers no guarantees. The next chance like this may come in 1,000 years, or never. It is up to each of us whether we let these mysteries fade into silence or ignite wonder and discovery. The choice is ours, and the record of our courage or our fear will last far longer than 3i Atlas itself. So as the object drifts beyond our reach, ask yourself, will we let this moment slip into shadow? Or will we finally demand to know what secrets lie just beyond the embargo? Because the search for answers is never truly over. It only moves to the next mystery, waiting for those bold enough to look. You are not only spectators to this cosmic turning point.
The public funds these missions, and the public deserves answers. Demand transparency. Demand curiosity. Do not allow the biggest questions in history to be settled behind closed doors and encrypted files. Only by choosing openness, by insisting, by probing, by refusing to let go, will we have any hope of learning the truth. Third, participate in citizen science. Projects like Zooniverse allow anyone to help analyze astronomical data. The more eyes on the data, the more likely we are to spot something unusual. First, support organizations and scientists who advocate for open science. Groups like the Open Science Foundation and researchers such as Avi Loeb are working to make data more accessible. By following them, sharing their work, and amplifying their message, you help build momentum for change. Fourth, encourage science education in your community. The more people understand the process and importance of open science, the harder it becomes for gatekeepers to keep discoveries under wraps. Second, stay informed and ask questions. When you hear of a new discovery, check if the data is publicly available. If it is not, write to your local representatives or to the institutions involved. Public pressure has led to the release of data in the past, such as with the Hubble Deep Field, which was made available following widespread demand. So, as 3I Atlas slips away, remember, the search for truth is a journey, not a destination. The next mystery is already on its way. Will we be ready? That is up to all of us. The story of 3I Atlas is not just about one object. It is about how we respond to the unknown. Do we retreat into secrecy and caution? Or do we embrace the risk of discovery? The answer will shape not just our understanding of the cosmos, but our legacy as a species. In the end, the universe is vast and mysterious, and its greatest secrets will not yield to the timid. If we want to know if we are alone, if we want to understand our place among the stars, we must be willing to look, to share, and to risk being wrong. Only then will we have any hope of finding the answers we seek. Finally, remember that every major leap in knowledge was made by those who dared to question, to demand answers, and to challenge secrecy. When Galileo first pointed his telescope at Jupiter, he saw moons no one else believed existed. When Vera Rubin insisted on publishing her data on galaxy rotation, she helped prove the existence of dark matter. These scientists were not content with silence. They pushed for the truth, no matter how uncomfortable.